To start this video, we'll start with a review of absolute value. So the absolute value of a number x, right? Say you have an absolute value that's just written as so. It's black. Why is it black? Okay. Let's say you have absolute value of x, that's written as so. You have the two vertical lines to either side of the value of the variable x, and that represents the distance x is from 0. All you care about is the distance. And mathematically, you would define it as such. You would say this is equal to x if x is greater than or equal to 0, and you would say it's negative x if x is less than 0. Well, pretty straightforward, right? The absolute value would be both positive and negative depending on the sign in front of the value of x. Thus, if x is a negative real number, then a negative x is a positive real number. Alright? The absolute value does not just turn minuses into pluses. That has been the general definition of absolute value, but it's not that. This is the logical reasoning behind the definition. So one example is that you can't say that the absolute value of 2x minus 1 is equal to 2x plus 1, right? It doesn't just turn the absolute value of 2x minus 1 into positive 2x plus 1 because you don't know if 2x minus 1 is a positive or negative number. Now, there are some properties, so let's just write down some properties here of absolute value. Okay, so the first thing is that the absolute value of x is always going to be greater than or equal to 0, regardless of what the value of x is, right? Because you're only looking at the distance of x from 0. That's the first property. Second property is that when you have a product of two numbers, that could be the same as the product of the absolute values. All right, when you have well, let me say that again. When you have the absolute value of a product, that is equal to the product of the absolute values of the numbers. All right. Now, for the third property, say you have the absolute value of 1 over x. And let's extend that a little bit more. That's going to be the same as the quotient of their absolute values. Right? Because the absolute value of 1, that's just 1. Okay, but that's only going to work when x is not 0, right? Because if x is 0, then this all falls apart. Fourth property is that if you have a negative number, that's going to be exactly the same as the absolute value of the positive, of its opposite. These are exactly the same. For the fifth property, you have what you would call the triangle inequality. It's a little bit complicated to understand if you've never seen it before. Okay, but it's basically saying that the absolute value of the sum of two numbers is always going to be less than or equal to the sum of their absolute values individually, right? Their individual absolute values. This is the triangle inequality. Triangle inequality. So why is this always the case? Well, you don't know if x or y is positive or negative. So if y is negative, here you have a subtraction. But if you do the absolute values of the numbers first, you're going to end up with two positive numbers. So here you have a bigger number than what you're going to have here. That's just one example. The last property is going to be that the square root of any number squared is exactly the same to its absolute value. Now let's look at a brief example. Let's say you have well, here you could also say that the squared inside the square root will cancel out with the square root itself, with the symbol, the radical symbol. You're left off with -3. However, this is not going to be -3. going to be 3, right? Because of the property up here, this is going to be equal to the absolute value of negative 3, and that equals 3. Now, why? Let's look at this in a different way. You have negative 3 squared on the inside. Well, those are two negative 3's multiplying each other. That gives you positive 9. So now you have the square root of positive 9, which is 3. Now, say you want to solve inequalities that include the absolute value in the expression. To solve that, let's just recall something. Let's say if a is greater than or equal to 0, then you would have the solution to the absolute value of x equals a is that x could be plus or minus a, right? Because if you have a negative number or a positive number inside the absolute value, all you're asking is the distance from that value to 0, or the distance from 0 to that value, which is going to be the value itself, but in the positive version of that value. Okay, so in cases where we are not sure if the right side is positive or negative, you must perform a check at the end. So let's have an example. Let's say you have the square root of 2x plus 3 equals 2 minus x. You're solving for this equation, and you don't know if the right side is positive or negative. So that means something. You have two cases here. You could have 2 plus 3 equals positive 2 minus x, or you could have 2x plus 3 equals negative 2 minus x. Alright, you just don't know. You don't know if the right side is positive or negative. So let's solve both of these cases. You have 2x plus 3 equals 2 minus x. Okay, you bring this 2 to the other side. You're going to be left with 1, and you're going to bring the x to the other side as well. You have 3x plus 1, so now you could have 3x equals minus 1. So now x is going to be negative 1 over 3 if the right side is positive. But if it's negative, you're going to have 2x plus 3 equals minus 2 plus x. Alright? So if you bring the 2 to the right side, and if you bring the x to the right side, no, the left side. If you bring the negative 2 to the left side and positive x to the left side as well, you're going to be left with x plus 5. So x is going to be negative 5 once you move the 5 back to the right side. Or you could have just moved the 3 to the right side. Since you do not know if the right side, right, a equals 2 minus x, right here, is positive or negative, you must perform a check of your answers. You must perform a check that your answers omit any that are incorrect. All right. So what does that mean? Well, if you say if x is in fact negative 1 over 3, right? So if x equals negative 1 over 3, okay, then the left side will be the absolute value of 2 minus 1 over 3 plus 3. Find the absolute value of that. That is going to be the absolute value of, well, you have minus 2 over 3, and then you need common denominator. That's going to be 3. So 3 times 3, that's 9. So that's, what's it called? 9 minus 2, that's 7. So you're going to have 7 over 3, the absolute value of that, which is 7 over 3. That's for the left side. But then the right side is going to be 2 minus x. So that's going to be 2 minus 1 over 3. Then you're going to have 2 plus 1 over 3. And same thing, common denominator, you have 6 up top over 3 here, and then 6, 1, and 7, so you have 7 over 3. Okay, good. The left side and the right side work for x being negative 1 over 3. Now, if you use the other number, if x is minus 5, and you do the same thing, then left side is going to be the absolute value of 2 times minus 5 plus 3. So you do minus 10 plus 3. That's going to be minus 7. And the answer is 7. All right. Let's do the right side on the right over here. Okay. The right side is going to be 2 minus 5. That's 2 plus 5, and that is 7. Okay. So in this case, they both work. So in this case, the left side equals the right side for both x equals negative 1 over 3 and weird A, and x equals 5, no, negative 5. Negative 5. So they are both solutions. All right. Now that was an equation to introduce how you would solve using both sides, considering a positive right side and a negative right side. What if you had an inequality? Now, say you had our next example. Say you have the square root of x minus 5. Square root? No, absolute value. We're doing absolute value. Less than 7. And you're trying to find all the values of x that would make that work. Another way of looking at this is considering all of the values that are in between negative 7 and positive 7. So another way of writing this would be negative 7 is less than x minus 5, and that's going to be less than 7. Now, you're going to add a 5 to the left side and the right side to get rid of the 5 in the middle, right? So you end up with negative 7 plus 5 is less than x. If you add 5 to the middle, you'll end up with x, and you have 7 plus 5. So now here you end up with minus 2 is less than x is less than 12. All right, there you go. That's the solution right there. X is going to be negative, in between negative 2 and 12. Those are the x's that will make this inequality satisfy. So you can say, therefore, x is in negative 2 to 12. Notice how you're using circular brackets to not include the endpoints. Let's have another example. Let's say you have the absolute value of 2 minus z, and that is less than 7. Well, same thing you're doing here. You have negative 7 less than 2 minus z is less than 7. You're going to subtract 2 on both sides, right? Because you have a positive 2 in the middle. So now you have minus 7 minus 2 is less than negative z. It's still negative, right? Because you didn't do anything with that. All you did was subtract 2 on both sides. And then you have that is less than 7 minus 2. So you have minus 9 is less than negative z. And that's going to be less than 5. Well, you're looking for the values of z, not negative z, right? So to get rid of that negative in front of the z, you're going to multiply by negative 1. And remember, when you multiply by negative 1, the signs change, right? So you're going to end up with 9 is greater than z, which is greater than minus 5. So when you rearrange, you can have minus 5, it's going to be less than z, it's less than 9, okay? And that's it. That's your solution. That's your solution that would make the inequality satisfy. So therefore, z is in between minus 5 and 9. Here's another example. Let's do a couple more. Say you have the absolute value of 2 minus z is greater than or equal to 7 now. Okay, so recall that a is greater than 0, and if you do the absolute value of x is greater than or equal to a, that means that x is less than or equal to minus a, or x is greater than or equal to a. Alright, so here's when you have the two cases. So you can do first 2 minus z is less than minus 7, or 2 minus z is greater than or equal to 7. Alright, so when you solve this, first you have minus z is less than or equal to minus 7, sorry. My z and 7's look kind of similar. Not quite though. Little tail here for the z. Minus 7, minus 2, so you'll get minus z is less than or equal to minus 9. You can multiply by 1 and change the direction of the inequality, so you have z is greater than or equal to 9, and on the right here you're going to have something similar. You're going to have minus z is greater than 7 minus 2. Alright, so that's going to be minus z greater than or equal to 5, and multiply by 1, and you change the direction of the inequality, so you have z is less than or equal to minus 5. Alright, so either z is greater than or equal to 9, or z is less than or equal to 5. Okay, so using interval notation, you could say that z is going to be in 9 all the way to infinity, or z is going to be all the way from negative infinity to negative 5, including that. Okay, now instead of using or, you would use the symbol. Well, you know what? Let's do it like this. The solution would be negative infinity to negative 5, union 9 all the way to infinity. Z is an element of this whole set. Now, in the previous two examples, the only difference is that one had the less than in the equation, only the less than, and the other had the greater than or equal to. Okay, one had the less than symbol and the other had the greater than or equal to symbol. Combining the two solutions gives the entire real number line. Alright, isn't that cool? That's kind of cool. Let's do one more. Say you have 0 is less than x minus 5, the absolute value of that, and that's going to be less than the absolute value of 7. Okay. Now, you split this into two cases. Alright, what are the two cases? Well, for the first case, let's say number 1. For the first part, you have 0 is less than x minus 5, and you take the absolute value of that. For this part, for 0 is less than the absolute value of x minus 5, remember that you always have an absolute value that is positive or 0, right? That goes back to the first part of this video. Okay, so for this part, you have to avoid the part where 0 is equal to the absolute value of x minus 5 from ever occurring. You have to avoid this. Alright? Thus, x cannot be 5. Okay? Because if x is 5, then you get 0 on the right hand. So here, you know that x cannot be 5. Okay, so let's just say avoid. For the second case, you have the absolute value of x minus 5. that is less than or equal to 7, you're going to have minus 7 is less than or equal to the absolute value of, no, it's just the 5. The x minus 5, sorry. The x minus 5 is less than or equal to 7. Adding the 5 to each side, you have minus 2 is less than x, less than or equal to x, and less than or equal to 12. Therefore, x is in the interval of 2 all the way to 12, and you're including the endpoints. To combine the first case and the second case, all you have to do is say that x is within this interval, but x cannot be 5. Okay, so how do you do that? Well, you would combine, just write this down, combine 1, 2. You would say that x is within, well, negative 2. You're not including 5, so you're going to go up to 5, you're not including it, and then you're going to join all the numbers after 5 all the way to 12. You have 5 all the way to 12, and you're including the 12. Notice the brackets. You have the square brackets for the bounds that you're including and the round brackets for the bound that you're not including.